Hello everyone, my name is Daniel Phillips. I am an astronomy student at Arizona State University and I present to you an ultra-diffuse galaxy called Dragonfly 44. It was believed to be made up almost entirely of dark matter, at one point believed to be up to 99.99% dark matter. Further observations are bringing that percentage down, but the galaxy is still considered mostly dark matter. This is not the most exciting galaxy to look at, but I chose it to investigate this particular galaxy because it contradicts an underdeveloped hypothesis I have about dark matter and galaxy rotation. We learned in Module 10 that our observations of galaxy rotation curves did not match Keplerian predictions. Specifically, that velocity should decrease as distance from the center of mass increases, just like our solar system or a spinning ballerina. When we look at our Milky Way and other galaxies, we don't see this Keplerian curve, but instead see stars at the edges of the galaxies maintaining very high speeds, suggesting there is a lot of matter unaccounted for. Dark matter, if you will. My idea for explaining this was a different form of MOND, modified Newtonian dynamics. MOND suggests the laws of gravity act differently at very low accelerations, like those found in the outer regions of galaxies. I looked at the massive size of galaxies, often hundreds of thousands of light years across, and wondered more about the speed of gravity. On such scales, would the speed of gravity be relevant and maybe change velocity curves, perhaps even matching actual observations? Either way, studying Dragonfly 44 has both discredited and given some support to my idea. Now I do know that MOND, and my idea as well, do not play well with galaxy clusters or the specific instances like the bullet cluster, but one thing at a time. I have some measurements of Dragonfly 44 to evaluate. It has a velocity dispersion of 47 kilometers per second and a radius of 4.6 kiloparsecs. Using a typical value for an elliptical galaxy of k equals 3 and plugging in the measurements of velocity and radius, we obtain a dynamic mass of 0.7 times 10 to the 10 solar masses. For comparison, our Milky Way is estimated to be about 1.5 times 10 to the 12 solar masses. The measured luminosity of Dragonfly 44 is 3 times 10 to the 8 solar luminosities. For comparison, the Milky Way is estimated to be 2 times 10 to the 11 solar luminosities. Using these measurements, we obtain a mass to light ratio of 23.33 solar units for Dragonfly 44, and again comparing it to the Milky Way as a ratio of about 7.5 solar units. What does all this mean? Using the mass to light ratio we just calculated, we find that Dragonfly 44 should have about 95.7% dark matter. This is a little lower than the original prediction of 99.9%. And this change is primarily because of better measurements over the last couple of years. What does this all say about my idea? It damages it a bit, but does not destroy it completely. If the original measurements had been confirmed and did show a galaxy with very little light but a lot of mass, my idea about the speed of gravity affecting rotational curves would not work. There just isn't enough luminous matter to make much of a difference. The reason it doesn't totally destroy my idea, or MOND, has to do with our measurements. As we look closer at this galaxy, we keep reducing the percentage of dark matter measured. When we get even more accurate measurements, we may find this particular galaxy is not so dark matter dominant after all. Its mass to light ratio might closely match our Milky Way or the average elliptical galaxy. It may not rule out some sort of MOND explanation after all. These calculations are dependent on the galaxy's luminosity, which in turn is dependent on its distance. And as we learned in Module 2, we can estimate the distance using an object's redshift. Dragonfly 44 has a measured redshift of z equals 0.023, and speed of light times the redshift gives us a velocity of 6,900 kilometers per second. Assuming a Hubble constant of 70 kilometers per second per megaparsec, we can estimate Dragonfly 44's distance to be 98.6 megaparsecs, or 321 million light years. I personally like to say 98.6 megaparsecs. It seems easier to remember for some reason. And this closely matches other objects in the Coma cluster, providing more empirical evidence of its actual location within this cluster. And that prompts another question. Why do we care that Dragonfly 44 is in the Coma cluster? Why is it important? Its location in the cluster gives more credence to the galaxy being much more massive than its luminosity alone would suggest. A galaxy that matched the actual luminosity of Dragonfly 44 without a lot of dark matter to stabilize it would have been torn apart by the gravity from other galaxies within the cluster. It's just more evidence for dark matter and less support for my own idea. Merry Christmas, everyone. I hope you have a lovely holiday.